All right, this is our guided practice 18. So we're going to tackle some surface area problems from section 8.2. So the first one is the sine of pi x. So we're revolving around the x-axis, so we want the surface area is equal to the integral from 0 to 1 of 2 pi y times the square root of 1 plus y prime squared dx. Okay, so we're going with respect to x, which is why I went with 0 to 1. And so our 2 pi can come out front, 0 to 1. My y is my function, sine of pi x. And then I'm going to have the square root of 1 plus. Now we go to the side and we say our y is sine of pi x. And so our dy is cosine of pi x times pi. Sorry, I'm going to change this notation for a second. To y prime. There we go. Okay, so when I plug that in, we get 2 pi, integral from 0 to 1, sine pi x, square root of 1 plus pi squared cosine squared pi x dx. Okay, so what we would do next is we would say, okay, well, let's think about what we can do here. We do see that we have a function, cosine pi x, and its derivative, sine of pi x. So the first thing we would do is make a u substitution for cosine of pi x. And then my du is pi times the sine of pi x, only we need it to be negative, dx. And so that means this is going to become 2 pi over negative pi, right, because that negative pi moves over. The integral, and I'm going to leave this boundaries off for now, or we can compute them. If you plug in 0, the cosine of 0 is 1. And if you plug in 1, the cosine of pi is negative 1. So we're going from 1 to negative 1. The sine of pi x and my dx becomes my du. So I just need 1 plus pi squared x squared. Sorry, pi squared u squared du. All right, now here's the problem. We've got something underneath the square root, and this is going to end up being trig sub. So I can do this for you. It's going to take a little bit of effort, but we can do it. Okay, what you would do is you would say, okay, now my u, I'm going to make that 1 over pi tangent theta. And then du is 1 over pi secant squared theta, d theta. But what's going to happen here is when I plug in the tangent, what's underneath the square root is going to become a secant, and then I already have a secant squared for du, so that's going to give me the integral of secant cubed, and it's going to get ugly really quickly. So I can do it, but I think I'm going to stop here, and we're going to just kind of let that go, and we would get an answer. I can get the answer for you. Let's plug it into a Wolfram Alpha situation here and see what it tells us. Right? And this is really the use for this type of thing, right? You have a definite integral that you want to find the value for. So we want to know what is 2 pi, or really our pi's are going to cancel here. Actually, let's go all the way to the top. So let's go to, let's see. I'm not sure why I didn't put this here, but we have pi squared cosine squared pi x dx here. So this is what I want to put in. I want to put in 2 pi. And maybe I'll do it on your screen so you can see it. All right, so go to Wolfram Alpha. We're going to go 2 pi times the integral from 0 to 1. And we have the sine of pi x times the square root of 1 plus pi squared And then we have cosine. Uh-oh, my cosine is not on the inside. I need to be on the inside. There we go. Cosine of pi x dx. There we go. Okay, so 2 pi, integral from 0 to 1, sine of pi x, square root of 1 plus pi squared cosine pi x, right? That's what we have right up here. Whoa, sorry, lost it. Right here in the middle. So 2 pi, integral 0 to 1, sine pi x, square root of 1 plus pi squared cosine squared. Oh, wait, I need to square my cosine. Okay, there we go. And go. All right. And you can see right away that the integral got pretty complicated. They used the Sinch's SINH hyperbolic sine functions, inverse hyperbolic sine functions to integrate it. You can use trig sub and it'll get you there. I just don't want to spend the time with that. So we end up with 7.78 as our answer here. So the arc length here is 7.78, okay? Of course, I am not going to give you something that difficult on a quiz or a homework or an exam. If something pops up like that on WebAssign, you are more than welcome to use technology to solve it once you have the right integral, okay? All right, so our second one here is x equals square root of 36 minus y squared around the y-axis. So we're around the y-axis in terms of y. So that means we have the surface area equals, y is going from 0 to 3. I'm going to pull my 2 pi out front a while. And we know that around the y-axis in terms of y, it's going to be 2 pi times x times the square root of 1 plus x prime squared dy, okay? So we're going to plug in our x for our function for the x. Oh, wait, sorry, I wrote in two pi's. There we go. Okay, so this is going to be 2 pi, integral from 0 to 3. This is the square root of 36 minus y squared, because that's our x equals function, times the square root of 1 of something, right? Let's go figure out what that something's going to be. So if we have x is equal to, I'm going to change colors here. We have x is equal to the square root of 36 minus y squared. That's 36 minus y squared to the 1/2. When you take its derivative, you get 1/2. 36 minus y squared to the negative 1/2 times negative 2y. The 2 and the 1/2 cancel, and you get negative y over 36 minus y squared to the 1/2. Now we're going to square that. And that gives me y squared over 36 minus y squared. We're going to add 1. And that is y squared over 36 minus y squared plus 1. So get with common denominators here, you're going to have y squared plus 36 minus y squared all over 36 minus y squared. Your y's cancel just like the one we did up above, and this is 36 over 36 minus y squared. And that's what goes underneath the square root. So that's what I'm bringing up here. So this is 36 over 36 minus y squared underneath my square root. Sorry, this is with respect to y. There we go. Okay, now again, like the one above, this square root and that square root are going to cancel, and I'm left with 2 pi times the integral from 0 to 3 of the square root of 36, which is 6. So this is 12 pi times the integral from 0 to 3 dy. And there's a 1 written there, so this is 12 pi times just y from 0 to 3. And so we get 36 pi. Okay. Again, these integrals can be really tricky. If they're really, really tricky, like the one in number 1, we can go ahead and use some software to help us out there. And if they're not, then we want to make sure that we can do all the work. So if you come up with something on WebAssign that's a really tricky integral, go ahead and just plug it into some kind of technology. And for an exam or a quiz, you'll have something that the algebra is going to work out nicely for. Okay.